So, all right, let's talk about settling, sediment settling. Settling means the sinking, gravitational sinking of particles through the water column. And this can be approximated by the so-called Stokes law. Again, there's a little equation where the W is the settling velocity. How fast does the sediment particle sink in terms of distance per time unit? And if you look at the formula, there are some parameters in there, and the most important one is the diameter of the particle squared. It doesn't come in here, it doesn't appear as a volume, it appears here as the square. Okay? And there's something called viscosity of seawater. It's related to the ambient fluid. G is acceleration due to gravity, it's a constant, and this difference here is the difference in densities. And also this is sort of, that can vary for different sediment terms, but it's also constant. So the key parameter is the size of the particles. That determines the rate of sinking, and it's also nonlinear. So the larger particles sink substantially faster. Okay, this is abstract, and in order for you to understand the significance of that, I converted it into examples. So here are the examples. Okay, so there is a table in yellow. You see this table here? And on the left side is something called D in millimeters, is the diameter of your particles. And some assumptions with looking at quartz type of particles, and it's all written up here, the parameter values used in Stokes formula. Anyway, we look at clay, silt, fine sand, coarse sand, pebbles, and we work out the vertical velocity, the settling velocity, and it's positive here, but it refers to sinking. And you can work out these numbers. Still, you don't understand the significance. So now what we do is we look at, take a lake if you want, something which has a depth of 10 meters. How long does it take for a particle to sink in the absence of any turbulence? It's absolutely still water. We release a particle at the surface and we count the time it takes to sink. And I can't show you that in real time, because for a very fine clay particle, you'd have to wait 3.9 months, almost 4 months, it would take to sink. Very, very long time. And if there's a little bit of turbulence in the water column, it can prevent the settling. So very fine particles stay in the water column for a long time. They can be mixed around and dissolved by currents and so, which gives you a dilution effect over time, but the particle is still there. So silt, 1.2 days it takes to sink 10 meters. Fine sand, 15 minutes. Coarse sand, 50 seconds. And pebbles, 12.6 seconds. So go to a lake which is 10 meters deep, take a pebble, 1 centimeter pebble, throw it into the water, takes 12.6 seconds to end up on the seafloor. And there's an important message. The problem are the very fine particles, and they come from continental runoff, stormwater runoff. That's the big issue. You can have pollution events for lasting a week or longer, where you have reduced light conditions, and this is because the fine material stays in the water column for a long time. So this is really important stuff.